Hi, very good morning. Today we are going to discuss about communication security in zone architecture. First of all, what is communication security? We discussed in the past that the zone controller will communicate with another zone controller with a high-speed link. Similar way it used to communicate with a high-performance computer, which is a central brain of software-defined vehicle. Right. This communication happens with using high-speed link, probably an automotive Ethernet, right? With different speeds that we have, they can choose what they want and can use it, right? The problem with this communication is if it is not secured, if it is not secured, there is a possibility of attack. Why they have to attack it? Okay, someone want to steal your vehicle. Then he want to know about the ECUs in the network, and then the more detail about your vehicle security. He can attack the vehicle network, these communication links, and can fetch the sensitive data about your vehicle and about your vehicle and the network structure. In this way, they can try to compromise the vehicle network so that they can steal, they can introduce some sort of malfunction in the vehicle, they can do these sort of things. Okay, what are the different ways they can do these attacks? Right, they can do an eavesdropping, meaning they can try to listen without your knowledge. They can try to listen your network traffic and can understand your network structure. This is called eavesdropping. Right. And then they can inject malicious messages to your network. They can do spoofing. By doing that, they can create some sort of malfunction in your vehicle, or they can take control of your vehicle. Man in the middle attack. So you're transmitting something, they can manipulate that content and can create some sort of malfunction. This is another way of doing attack, communication attack. They can remove your access to certain services of the vehicle. That means they can remove you from those service subscriptions so that you cannot access those data or those details. Right? Then unauthorized ECU access. They can influence the ECU memory without any security access. By default, in every automotive ECU, they used to implement something called a security. When you want to do some sort of manipulation in the ECU memory, first you have to move to a certain DIAG session, right? Probably extended or programmation. After that, you have to gain something called a security access. Those who studied CAN course with us, right? The automotive system course with us. For them, we detail that in the very beginning. Oh, sorry. In that one, we are having a module called diagnostics. When we explain diagnostics, we are explaining how the security access works. Right. You can refer. We have few videos of those in our channel. You can refer those videos to understand what are the security access is. These attackers, without getting the security, without gaining the security, we have to follow a process to gain the security. Without following those process, they can gain the memory access so that they can manipulate the content in the memory, which leads to malfunctioning of the vehicle. These are the different ways that they can make an attack in the vehicle network, in communication, vehicle communication. What is the result? As they are doing this, the security of the vehicle is compromised. So the architecture that we promoted collapse, right? So as there is a compromise, as there is a loophole in the communication. So it is not a trustworthy one. Right. Next, we have decoupled in software defined vehicle. We decoupled your IOs and then the computation units. That decoupling will break, right? So that again, it can create a malfunctions. The vehicle can create an unsafe behavior, right? That is another. It should work within the safe limit. As the security communication is compromised or the security of the communication is compromised, it can do unsafe vehicle behavior, which leads to lots of loss of customer and then brand value. These are the impact that is created by security failure in communication right now. Okay, to address that, what we can do, we have to implement this, we have to secure the communication. What can we do for that? There is a holistic cyber security approach. There are a lot of standards and regulation developed to strengthen the security. So for example, we have SAE 21434, cyber security engineering standard, which details how can you design a system with security. Then we have ISO 26262, which is a functional safety standard that details about the functional safety of the system. So we can follow these standards to secure the communication using a holistic cyber security approach. Right. So the holistic cyber security approach has different steps. First, you have to analyze your threats. What are the different threats that you are going to face, and then you have to implement by following these security standards. You have to implement your system in a secured way. Once the secured system is implemented, we have to verify it and then validate it. It is working without any problem. And then if there is a security threats detected, there should be a mechanism to report that incident. Right. When there is a security threats, in that time system should move to secured operation mode and monitoring of the threats. Right. As we told, we can do the design itself. So we can secure the communication by its design. That is another one. We have to have a right risk management in place. That is called as holistic cyber security approach. For that, we need these standards and regulation in place. Only then we can achieve it. When we implement these security standards, the benefits we get is data integrity, authenticity, confidentiality, availability, and accountability. These are the different benefits that we get when we implement the security in communication. Right now.